Okay, hello. Welcome to my lightning talk about balanced diets on resilient foods in abrupt sunlight reduction scenarios. You can connect with me via the presentation form. So onfed.info/Alix, and this form will be active during the presentation and to the end of the conference. So feel free to do so. The research I'm going to present is based on this paper, which basically tries to answer the following question: how to feed the Earth in a nuclear winter, or in any other abrupt sunlight reduction scenario. So first thing first, what is an abrupt sunlight reduction scenario? There are different types of catastrophe that can lead to this. A comet or asteroid impact, also a strong volcanic eruption, and maybe more concerning these days, a nuclear war. And we'll be focusing on this one from a model from Koop et al. Published in the JGR Atmospheres journal in 2019. In this model, ash is propelled into the atmosphere and it creates an abrupt reduction in the sunlight reaching Earth, which can lead to an agricultural collapse and then also a potential global starvation. And to answer how would we feed people in this scenario, we first need to understand what a balanced diet is. So as humans, we have nutritional needs, and those are different macronutrients, so proteins, fats, carbohydrates, and also micronutrients, so minerals and vitamins that your body needs to function properly. The following question is, how harmful is it to be outside of the recommended intakes? So in this research, we defined 3 different categories of intakes. So adequate intake, which is a healthy intake, and when you go outside of this adequate intake, you have a moderate risk associated intake, and further away, when you have even more risk, a severe risk associated intake. Based on those definitions and assumptions that we made, we were able to define different periods following the onset of the catastrophe where we could be feeding on different kinds of foods. In the first period, we would feed mainly on food stocks. Staple crops like wheat, barley, canola, maize, rice, and soybeans, and also the potato, which is a cold-tolerant crop. We would also be able to feed on fish and livestock. Meat might be available at higher levels than usual because of lower feed availability. We could also feed on their organs and on their milk if they are able to graze. And the missing calories could be taken from sugar from beets. Here is a summary of the different foods available. And using them, we made 2 different scenarios, an optimistic and a pessimistic one, that I'm going to present and show you the different deficiencies in nutrients. In this period, the pessimistic scenario is when food stock are not available anymore and we have eaten up everything. So there are no grains available, no wheat, barley, canola, maize, rice, and soybeans. So here is the different nutrients that would be available in the different diets in those different scenarios. And you can see here that there are deficiencies in vitamin E and D in both scenarios. And in the pessimistic one, you also have drastic deficiencies in essential fatty acids, also in fibers, and in vitamin K. So this can help us understand how we could mitigate those if in the event of such a catastrophe. In a second period, we would be able to feed mainly on potatoes, and staple crops would be available at the lower stocks. We hope that at this time, greenhouses would be ramping up, so we might have some staple crops available from there and also from crop relocation. And we think that we might have a good chunk of our diet that could come from farmed seaweed. That could be a significant contribution to the diet because it can be farmed in low light levels. It's not competing with land-based farming, and it can also be scaled up really rapidly. So that would be maybe available within 6 months after a disaster. So here is also a summary of the different available foods. And in this period, the pessimistic scenario is where seaweed has not been ramped up and is not available. And all of the missing calories are filled by lignocellulosic sugar, which is repurposing paper and pulp mills to produce edible sugars from plant matter. So here is a summary of the different nutrients and their associated intakes. You can see here that there's still a deficiency in vitamin D and also in vitamin E, especially in the pessimistic scenario. And you also have a deficiency in iodine in the pessimistic scenario. And then the last period that we defined is period 3, where we hope that staple crops would be available at higher levels because of greenhouses that have been built, crops that have been relocated, and potentially alternative resilient foods that have been ramped up. So full ramp up of seaweed, but also maybe of single cell bacteria, single cell proteins, that come from bacteria that feeds on, for example, methane and can be produced independently of agricultural conditions. And in this period, fish and meat are now less available. We will see that it results in a deficiency in vitamin A. And in here, we chose as a pessimistic scenario, a scenario where greenhouse production has not been scaled up sufficiently, so rice, maize, and soybeans are unavailable. Here's again a summary of the different available foods and the nutrients, the nutrient distribution. So same here, vitamin D, vitamin E is also deficient, a bit of vitamin E now because of meat and fish. And you also have different deficiencies in minerals. So to conclude, in this study, we wanted to better understand the nutritional landscape in an abrupt sunlight reduction scenario, where decreased temperatures and decreased rainfall does not allow us to have the usual foods that we would be eating. And so we were trying to understand what kind of resilient foods we could ramp up and investigate so that we can provide a balanced diet to people. And I would like to highlight that adequate preparedness is essential and indispensable to achieve the goal of feeding everyone, no matter what, especially in those conditions. Thank you for your attention. Again, you can connect with me via the presentation form link here, and I'm happy to take questions.
Thank you so much. I'm not sure what I'm most looking forward to eating, sugar from paper, seaweed, or methane-fed bacteria. You should Fed should organize a dinner once where we get to try all these different things. I think we had a question over here.
Hi, yes, Sawyer Bernath from the Berkeley Existential Risk Initiative. You mentioned that preparedness is really important. When you're modeling these situations, how much do you assume that nothing has been done other than planning prior to the disaster happening? Because I know you're talking about greenhouses ramping up and all these kind of things, and are some of the models assuming well, we've started to build the greenhouses and figure out some of these processes ahead of time, or yeah?
What we assume in this scenario is that we have the knowledge that we have right now in terms of what is possible at the industrial level, and what is available, what we have right now, and that at the onset of the catastrophe, we would know already, as we know, for example, at Fed, how to produce all of those things in the matter of time that we have. So nothing has been done prior to the event that is a direct consequence of shifting, for example, all those foods in the tropics, in greenhouses, and nothing more that we already have today. Does that make sense?
Are there any implications here for preparatory work in advance, for example, in the storage, large-scale reserves of seeds of different kinds, not for the sake of preserving genetic biodiversity, which is already in hand, but simply to have that reserve in emergency in the same way that already exists for various scarce raw materials?
I'm not sure I got the question itself. Sorry.
In your current presentation, there's no assumption about prior preparedness in advance of this event. So I was just speculating on what forms of preparedness could be appropriate and wondering whether there was an equivalent on the food front of what you could do already with scarce strategic raw materials. In other words, have a large-scale stores of seeds of the kinds that you were thinking would be growable in these reduced circumstances.
Yes, I think if we were able to prove that in such a scenario there are some kinds of species or seeds or specific varieties that could be useful, then yes, it could be part of preparedness to actually put them in a place where we could find them in this kind of events. Yeah, but it's not about food stockpiling or the likes. It's yeah, about seeds. It could be really interesting if we were able to understand which one would be useful in those scenarios. For now, I think we're more looking for seeds that would sustain drought and really warm climates. But the other way around could also be very interesting.
Well, thank you so much for your time. Thank you for that.
Thank you for having me.